So it's January. And for millions of people, that means it's time for the annual quest for self-improvement.
Right. The New Year's resolutions.
Exactly. We set these huge goals, get fit, learn a new skill, finally stop doom scrolling at midnight, and then what happens?
Well, a few weeks in, things start to crumble. And we immediately blame ourselves. We think, oh, I just don't have enough willpower, or, I'm not disciplined.
It feels like a personal failure every single time.
It's this really frustrating ritual, and it happens because we're looking at it all wrong. Our sources are pretty clear on this. This isn't a problem of character. It's a problem of biology.
Yeah.
You are literally fighting the physical structure of your own brain.
Okay, so let's unpack this. For our deep dive today, we're going to get into the neuroscience to figure out how to stop fighting ourselves. We'll look at the neurobiology of why change is so hard, and then, this is the important part, we'll lay out some specific brain-based strategies to build habits that actually stick.
And we'll pay special attention to what this means if you're someone who deals with, say, attention challenges or executive dysfunction.
Right, because the standard advice doesn't always apply.
It really doesn't.
Yeah.
We need to completely reframe this. It's not about a moral struggle. It's about neuroplasticity. When you form a habit, you're not just, deciding to do something. You are physically rewiring your brain.
You're changing the hardware.
You're changing the hardware.
Yeah.
Our sources get into the mechanisms, things like Hebbian theory, myelination, and then connect it to practical behavioral science. It gives us a kind of blueprint for making real change.
Okay, so let's start with that wiring, the absolute foundation. I think everyone has heard that phrase, neurons that fire together, wire together.
That's the one. It's the core of Donald Hebb's theory, and it's basically how all learning works at the micro level. When you repeat an action in response to a certain cue, you're creating an association.
So, I see a full sink, and I wash 3 dishes.
Exactly. Neuron A, for full sink, repeatedly fires and excites neuron B for wash dishes. And every time it does that, a little growth process happens that makes it easier for A to fire B the next time. You are literally carving a path in your brain's landscape with every single repetition.
But why does that new path feel so awful, like slogging through mud, while the old habits feel completely effortless? What's the difference in the actual infrastructure?
The difference is speed, and that speed comes from something called myelination.
Myelination, okay?
Think of it like insulation on a high-speed internet cable. Myelin is a fatty sheath that wraps around the axons of your neurons. This insulation makes the electrical signal travel incredibly fast and efficiently.
So our old established habits.
They're running on these super insulated, myelinated superhighways. The signal is almost instantaneous. It's automatic.
Which means the new habits are, what, dirt roads? Unmarked trails?
Precisely. They're unmyelinated. And to use them, you have to engage your prefrontal cortex, your conscious, rational brain, every single time. That takes a huge amount of effort. It's metabolically expensive.
It burns more energy.
It burns a lot more glucose and oxygen. And your brain is, above all, an efficiency machine. It's programmed to save energy. So it creates this internal resistance, this what our sources call limbic friction.
So that little voice that says, ugh, I don't feel like it. That's not me being lazy.
It's your brain trying to conserve resources by defaulting to the superhighway it already built. It's a biological drive for efficiency, not a character flaw. It's a huge, huge reframing.
It really is. So let's say we push through that friction. We keep taking the dirt road. How does the brain know when to pave it? What's the neurological shift from effort to automatic?
It's a fascinating handoff of power.
Yeah.
In the beginning, the behavior is goal-directed. It's run by the ventral striatum and the nucleus accumbens, or NACI. That's the emotional, reward-seeking part of your brain.
The part that's asking, is this worth it? What do I get out of this?
Exactly. It's the motivational boss. But as you keep repeating the behavior, something crucial happens. Control shifts away from that emotional, high-energy system.
To where?
It shifts to the dorsal striatum and the basal ganglia. Think of the basal ganglia as your brain's automation department. It's autopilot. It doesn't ask why anymore. It just executes the sequence. The question shifts from should I do this to this is just what happens next.
So the wanting part, the emotion, gets decoupled from the action itself.
Completely. The behavior is now just a chunked motor sequence. There was a great rat study that showed this. The rats learned a maze and they hit peak performance after about 5 sessions. They looked like they had it down perfectly.
Okay.
But the researchers kept monitoring their brains. And they found that the neural activity in the basal ganglia kept changing and optimizing for another 7 sessions.
Wait, So even after they got as good as they were going to get, their brains were still working on it for more than double the time.
Yes. Performance just shows you learn the task. The continued neural change shows the brain is still streamlining the process, building that myelin superhighway, making it faster and more efficient long after you think you're done learning.
Which leads directly to the question everyone asks, how long does all that streamlining actually take? Because we've all heard the pop psychology myth. It's 21 days, right?
21-day myth. We can trace that back to a book from 1960 called Psycho-Cybernetics. The author was a plastic surgeon who just noticed it took his patients about 3 weeks to get used to a new face. It's an anecdote, not data.
So what does the actual behavioral research say? What's the real number?
The real number is, well, it's messy. It varies hugely based on the person, the habit, the situation. The research shows a range from as fast as 18 days for something simple,
18. Okay.
all the way up to 254 days to reach 95% automaticity.
Whoa, 18 to 254. That completely blows up the 21-day idea.
It does, but there's a key number in there that helps set expectations. The median time, the middle of the road, is about 66 days.
66. 2 months.
Roughly. So if you're at day 30 and you feel like giving up, you haven't failed. You're not even at the neurological halfway point for most people. You just have to normalize that duration.
That reframes the struggle completely. Speaking of framing, let's talk about identity. Our sources say that's also hardwired in the brain.
It is. Identity isn't some abstract concept. It's a collection of self-referential neural patterns. If you constantly tell yourself, I'm not a morning person, that thought reinforces a heavily myelinated pathway. Your brain uses it to predict your behavior.
So if I try to force a new behavior, like waking up at 5 a.m., but I still believe I'm not a morning person, I'm creating this massive internal conflict.
You're fighting your own predictive network. The new action is seen as an error, an attack on your brain's consistent model of who you are. And here's the crucial part. Your brain believes evidence, not just positive affirmations.
So I can't just tell myself I'm a morning person.
No. The only way to change that identity is to accumulate so much behavioral evidence to the contrary that the model is forced to update. You have to be the runner before you feel like a runner. You feed the brain undeniable proof.
Okay, that makes sense. So let's pivot to the practical side. How do we make this easier? The sources say is start with really precise goals.
Precision is key because it lowers the cognitive load. And the research is interesting here. It shows people who phrase their goals as I will do something are far more successful than people who use I won't.
So focus on the positive action, not the restriction.
Exactly. Focus on what you're doing, not what you're resisting. So instead of a vague goal like eat healthier, you need a specific, repeatable action. Maybe the big goal is a marathon, but the habit is a 15-minute walk 3 times a week. Start there.
You're not aiming for intensity, you're aiming for repetition. That's what builds the myelin.
That's it. Repetition over intensity, especially at the start. And the real game changer for reducing the need for willpower is what the sources call situational strategy, or environmental reengineering.
So it's not about having more self-control.
It's about needing less of it.
Yeah.
People with high self-control aren't constantly fighting temptation. They're just better at avoiding it in the first place. They play offense.
Give me an example of how that works neurologically.
Okay, so think about the research on smokers. Their relapse rates shot up just by being exposed to cues like seeing a cigarette ad at a checkout counter, even if they weren't consciously craving one.
Why?
Because the environmental cue automatically triggered that old myelinated superhighway. It engaged the basal ganglia's autopilot loop without any conscious desire. The environment itself pulls the trigger.
So we have to hijack our own environment.
You have to. You engineer your world to support the new path. It can be simple things. Research on food proximity shows that just moving cookies from your desk to a high shelf drastically cuts consumption. If you want to exercise, put your running shoes where you literally have to trip over them in the morning.
And that's especially important for anyone dealing with attention deficits, right? Where just starting a task is the hardest part.
Absolutely. For anyone with a higher cognitive tax on task initiation, reducing that friction is everything. And one of the best ways to do that is a technique called habit stacking.
Right. Tell us about that.
Habit stacking is brilliant because it uses a pre-existing cue. You just add a new behavior immediately after an old stable one. The formula is, after I do X, I will do Y.
So after I pour my morning coffee, I will stretch for 60 seconds.
Perfect. You're piggybacking the new habit onto a routine that's already a myelinated superhighway. The old habit becomes the trigger for the new one, which dramatically lowers the barrier to starting.
I love that. Let's spend a bit more time on strategies for listeners who do struggle with those executive functions. The sources has some really specific advice based on neurochemical timing.
They did. The first tip is to schedule your hardest new habits for the morning. That's when your body's natural levels of dopamine and norepinephrine are at their peak right after you wake up.
So you're surfing your body's own neurochemical wave.
You are. Dopamine helps with focus and motivation. Norepinephrine helps lower the resistance to getting started. You're using your biology to your advantage. A second key strategy is attention training itself.
Like meditation.
Exactly. Practicing something like mindfulness strengthens the circuits in your prefrontal cortex that literally control attention. And if you can control what you pay attention to, you can control which pathways your brain reinforces and myelinates. You're training the part of your brain that directs traffic onto the new road.
That's powerful. Treating attention as a muscle you have to build first. What about rewards? Can we speed up this whole process?
It seems like we can. Research on high-reward tasks, like addiction models in rats, show that the shift from the emotional brain to the automated brain, well, it happened much faster, as quickly as 15 days.
So a strong, immediate reward accelerates the myelination.
It suggests that yes. So if the task itself isn't rewarding, like, I don't know, doing your taxes, you need to engineer an immediate, high-quality reward right after you finish. And it has to be consistent. That signals to the brain that this new pathway is a high priority for automation.
Right, now for the paradox.
Okay.
We've talked about making it easier, but the sources are very clear that growth and plasticity, they don't happen when we're comfortable.
No, they don't. You have to be at the edge of your abilities. Because when you're in that state of productive struggle, your brain releases neuromodulators, like norepinephrine and acetylcholine.
And what do they do?
They're like a neurochemical highlighter pen. They mark the moment and send a signal that says, pay attention, this is important, encode this. That's the chemical trigger for lasting plasticity.
So if it's too easy, the brain just reinforces what's already there. It stagnates. The discomfort is literally the signal that rewiring is happening.
That's it, exactly.
Yeah.
But all that effortful rewiring is wasted if we don't consolidate it. And that brings us to the critical role of rest, the timing paradox.
The idea that the hard work happens during the day, but the permanent change happens at night.
Yes. Sleep is non-negotiable. During the day, you're making temporary changes in your brain, something called early phase long-term potentiation, or LTP. It's like saving a file to your computer's RAM.
It's temporary storage.
Right. Sleep is what converts that temporary change into lasting structural change. Late phase LTP. That's like saving the file to the hard drive. The sources are clear. Sleep deprivation, especially less than 6 hours a night, cripples that consolidation process. You can do all the work, but if you don't sleep, the changes don't stick.
It really ties it all together. So bringing it all home, what's the main takeaway for someone who's tired of the willpower fight?
The main takeaway is to stop seeing it as a moral failure. Change is a conflict between neural architectures. It's your old, efficient superhighways versus the new dirt road you're trying to build. Success means being a strategic construction worker, not just a motivated driver. You build the new road through repetition, you manage the environment, and you let your brain's own drive for efficiency eventually take over.
So when you understand the science, the shift to the basal ganglia, the need for myelination, the role of sleep, you stop fighting yourself. You start working with your neurobiology.
You collaborate with it, and that makes the whole process manageable and actually understandable.
It really does. Okay, to leave you with one final thought to build on all this, let's consider something called the habit discontinuity effect.
This is a fascinating concept.
It is. Research shows that when your environment is suddenly disrupted, you move, you change jobs. One study even looked at a London tube strike. All the old cues that trigger your habits vanish. This creates this incredible window of opportunity where those old pathways are quiet, and it's much, much easier to build new ones.
The old autopilot is temporarily offline.
Exactly. So think about that. What small, sudden disruption could you introduce into your own environment today? Could you just rearrange your office, change your commute? Something to shake up the cues and create that powerful window to start building a new you. Thank you for joining us on the Deep Dive.